Okay, greetings and salutations. Let's go over review problems, then we'll get on to the assignment. So the square root of 54, okay, you need to simplify that. 54 is not a perfect square, so it would be an irrational square root. Here, I'll use my blue pen until it runs out. So I put divided by, and I see what perfect square of 54 divides by. So 54 divided by 49, no. 36, no. 25, nope. 16, nope. 9, yes. So we rewrite that as the square root of 9 times the square root of 6. Okay, so the square root of 9 equals 3. So there's your answer, 3 times the square root of 6. Okay, now if I'm multiplying square roots, I break it down into 3 steps. Okay, now if you remember the first thing, if you have any outside coefficients, you multiply those, but I don't have any outside coefficients, okay? So I multiply the square roots together. So we take 6 times 21, that gives me 126. Then I take the x squared times the x to the third, and that's x to the fifth. Now, step 2, you simplify your new square root. So you got this, you want to break that up though, okay? So that you got the square root of 126 and the square root of x to the fifth. So 126 definitely is not a perfect square, it's irrational. So I divide. So 126 divided by 121, nope. Divided by 100, nope. 81, nope. 64, nope. 49, nope. 36, nope. 25, nope. 16, nope. Okay, it divides by 9, so I make the square root of 9 times the square root of 14. Okay, and then the square root of 9 turns into 3, so we have 3 times the square root of 14. So in my new square root, I'm going to have 3 outside as a whole factor, and then 14 inside as a square root. Now we have to do the x to the fifth. So x times x times x times x times x, and then we put the square root, break the square root down further so it covers 2 x's at a time. And the reason for that is because x times x is x to the second, and the square root and the second cancel, giving me a full factor of x. Cancel full factor of x. And then this x here will just remain in the square root because it doesn't have a second power to cancel the square root. So the 2 full factors of x multiply to x to the second, and then the square root of x that's remaining. So I'm going to have an x to the second outside and an x inside. Now the third step is to multiply out, to simplify the outside, but you really can't because you don't know what x is, so it's going to be 3x to the second times the square root of 14x. Okay, my next problem, we have 8 square root of 2 minus, make that plus negative. Okay, so with the plus sign, okay, unlike the times, with the plus sign you have to get like terms. That means you need to get your square roots to match if you want to add the outside coefficients. Can't add those because 8's multiplied by the square root of 2, negative 3 is multiplied by the square root of 18. So to get like terms, make your table. So you got 8 times the square root of 2 on one side, and then negative 3 times the square root of 18 on the other side. So 2 is not a perfect square, so that's irrational. So we put the division sign in. 8 times square root times square root. The only thing 2 is going to be divisible by is 1. Well, dividing by 1 is kind of pointless. So I don't know why I did that. Just drop your 8, okay? I don't know. I shouldn't have wrote that. Okay, 2 divided by 1, the only thing it divides by is 1, which means the square root just stays the same. Because you divide something by 1, it's just the identity property. So 8 times the square root of 2, that's already in simplest form. Now the other one, the square root of 18, is an irrational square root. It's an irrational number. So I put the division sign, and I see what 18 is divisible by. You want to drop the -3 coefficient. That doesn't go away. But for now, we're just focused on the square root of 18. So 16 is a decimal, and then we get 9 and 2. So we put square root times square root, then 9, 2. Okay, so the square root of 9 equals 3. So now this square root of 18 now becomes 3 times the square root of 2. And then, of course, -3 times 3 would be -9 times the square root of 2. Remember, you can't multiply a whole number by a square root. Okay, now we have our like terms with the square root of 2. They're both multiplied, both the 8 and the -9 are multiplied by the square root of 2, so we can add these. 8 plus -9 is -1. Okay, now the next one. We have a quantity, a parentheses. We have 3 times the square root of 3 plus the square root of 6, and we can't add these. Okay, if you want to put a 1 there, I would do it. 3 and 1 can't be added, though, because we have different square roots. Okay, times 7 plus the square root of 7. So if you want to put a 1 there, you can. So we can't add these, and we can't add these. So we need to do the FOIL method. So remember, do it from your outside whole numbers. So 3 to 7, 3 to 1. But when I multiply the 3, you need to write 3 times the square root of 3 times 7. And then 3 times the square root of 3 times 1 times the square root of 7. You got to include the square roots on your whole numbers when you multiply them. That's distributed. Now we do 1. 1 to 7, 1 to 1. But it's 1 times the square root of 6 times 7. 7's not multiplied by anything. Then 1 times the square root of 6 times 1 times the square root of 7. That's what we did in the last lesson. Okay, so figure these products. So 3 times 7 is 21, and then you just have the square root of 3. 3 times 1 is 3, and then the square root of 3 times the square root of 7 is the square root of 21. 1 times 7 is 7 times the square root of 6. 1 times 1 is 1 times the square root of 42. Okay, so now you write these products over here. Give yourself some room. Times 7 times the square root of 6, 1 times the square root of 42. Okay, now square root of 3 is not, you simplify these products, okay? 3 is not a perfect square, it's irrational. So you put the division sign. The only thing 3 is going to divide by is 1, though, okay? So we're going to circle that, it's already in simplest form. 21 is not a perfect square, it is irrational, okay? So you put in your division sign. And you'll drop your, and then see what 21 divides by. 21 divided by 16, nope. 9, nope. 4, nope. So again, that's just 1, which means that's already in simplest form. Okay, the square root of 6. Can you divide 6 by 4? Nope. You can only divide it by 1, which means it's in simplest form. That's irrational, but the square root of 42 is irrational. It's not a perfect square, so I start dividing. Is 42 divisible by 36? Nope. By 25? Nope. By 16? Nope. By 9? Nope. By 4? Nope. Okay, so now we're just at 1. Okay, so that means that's simplified. So all those were in simplest form. Now, you don't have any whole numbers without square roots to add together. Okay. So you got the square root of 3. Do you have anything else multiplied by the square root of 3? No, we don't have any other square root of 3 terms, so it's just going to be 21. Plus, then you got the square root of 21. Well, we know we got that 3 times. Do you have any other square root of 21? No, so it's just 3. Square root of 6. You got the 7. Do you have anything, any other, is that a square root of 6? Nope, so it's just the 7. And then the square root of 42, that's just the 1. There we go. Okay, now, now, this is another FOIL problem, but something weird's going to happen. 3 times the square root of 2 plus 3 times 3 times the square root of 2 minus 3. Put plus negative. So again, you can't add your whole numbers because you got one multiplied by the square root of 2, then the other one's not multiplied by anything. Likewise here. So you're going to do your FOIL method. So you go from this 3 to 3, 3 to negative 3. So it's 3 times the square root of 2 times 3 times the square root of 2, and then times negative 3. That's distributed. Now the 3. Now this 3 is not multiplied by anything, and I multiply it by the same two things. 3 times the square root of 2, negative 3. So 3 times 3 is 9. The square root of 2 times the square root of 2 is the square root of 4. 3 times negative 3 is negative 9 times the square root of 2. 3 times 3 is 9 times the square root of 2. 3 times negative 3 is negative 9. No square roots. Okay, so we have 9 times the square root of 4. Negative 9 times the square root of 2. Positive 9 times the square root of 2. And negative 9. Okay, so the square root of 4 is actually not an irrational number, it's 2. So I drop the 9 and just replace that with the whole number value of 2. So 9 times 2 is 18. Okay, no square root. Square root of 2 is irrational because it's not a perfect square, but if you divide, the only thing that's possibly going to divide by is 1. So that's already in simplest form. Same thing here. Do we know the square root of 2, the only thing that divides by 1, that's already a whole number. So then we combine the whole numbers by adding. 18 plus negative 9 is 9. Then you have a square root of 2, but see, a funny thing happens. These are both multiplied by the square root of 2, but negative 9 plus 9 is 0. So if you get 0, you get rid of that, and the answer is just 9. Okay, because 0 times anything is 0. It doesn't matter if it's a square root or whatnot. Okay, next problem. 1 times the square root of 7 plus 6 times 1 times the square root of 7 minus 6. Okay, so we can't add. You can't add a square root to a whole number. Okay, so I have the 1 there for the distribution. So 1 to 1, 1 to negative 6. But this 1 here is multiplied by the square root of 7. That will be multiplying that by 1 times the square root of 7. And then negative 6. Then we do the same thing with the 6. Now 6 is not multiplied by anything. So I multiply it by the same two things. 1 times the square root of 7, then negative 6. So 1 times 1 is 1. The square root of 7 times the square root of 7 is the square root of 49. 1 times negative 6 is negative 6 times the square root of 7. 6 times 1 is 6 times the square root of 7. 6 times negative 6, negative 36. So we have 1 times the square root of 49, negative 6 times the square root of 7, positive 6 times the square root of 7, and then negative 36. So the square root of 49 equals 7. I mean, that's not an irrational square root, so we just replace that with 7, and 1 times 7 then is 7. Square root of 7 is irrational. So you put in the division sign. 7, is it divisible by 4? No. And then it's just 1. Okay, so that's already in simplest form, as is this one, and then that's already just a whole number. So we combine the whole numbers. 7 plus negative 36 is negative 29. Now, you got the square root of 7, and that has a square root of 7, but a negative 6 plus a 6 is 0. Okay, so then we don't have anything then. So it's just negative 29. Okay, next one. 2 times the square root of 5 plus 2 times 2 times the square root of 5 minus 2, or plus negative. Okay, so the 2 to the 2, the 2 to the negative 2, but it's the 2 times the square root of 5 you need to write down from here, and then you're going to take it times 2, but that 2 is multiplied by the square root of 5, And then the negative 2 just does not multiply by a square root. Okay, then the 2, positive 2, but doesn't have a square root. Then you multiply it by the same two factors, 2 times the square root of 5, and then negative 2. So 2 times 2 is 4. The square root of 5 times the square root of 5 is the square root of 25. 2 times negative 2 is negative 4. And then the square root of 5. 2 times 2 is 4. Square root of 5. 2 times negative 2 is negative 4. So we have 4 times the square root of 25. Negative 4 times the square root of 5. Positive 4 times the square root of 5. Negative 4. Now I'm going to show you something else. When the middle two are the same except you have a positive and a negative, you know that those are just going to cancel out. You don't have to worry about those. Okay. Notice out here there was always adding to 0 because you have a negative and a positive, the exact same term. So they're going to cancel out. So that's a quick way to do it. So 25 is not, square root of 25 is not irrational. It's equal to 5. So we have 4 times 5, and that's 20. And then negative 4 right there. So you add 20 to negative 4 and you just get 16. Okay, 8 times the square root of 10 plus 4 times 8 times the square root of 10 minus 4. So 8 to 8, 8 to negative 4. So it's 8 times the square root of 10. And then times 8 times the square root of 10. And then the negative 4. And 4. Okay. 4 times 8 times the square root of 10. And then 4 times negative 4. So 8 times 8 is 64. Square root of 10 times the square root of 10 is the square root of 100. 8 times negative 34 is negative 32 times the square root of 10. 4 times 8 is 32 times the square root of 10. And 4 times negative 4 is negative 16. So we have 64 times the square root of 100. Negative 32 times the square root of 10. Positive 32 times the square root of 10. And then the negative 16. So again, the middle two terms, I mean, they're both multiplied by the square root of 10, but you have a negative and a positive of the same thing. So when you add those, the negative and the positive cancel, meaning they add to 0, and there you go. So the square root of 100 is not an irrational, it's 10. So 64 times 10, and that's 640. And then we have the negative 16 in simplest form. Now we just need to add these two whole numbers. So 640 plus negative 16 is going to be 624. Now, you notice on all these problems we got whole number answers. And the reason for that is because the parentheses matched, except you had a positive and a negative on the whole number. Positive and a negative on the whole number. Positive and a negative on the whole number. See, it was the same thing in each parentheses. Those are called conjugates. Conjugates. Meaning that the term with the square root is the same, but then the whole number is just switched to the opposite. And that's going to be important moving forward.